Topic 1, Lesson 2, second section of this lesson will be on temperature, and this will be a very short podcast. We'll be talking about what temperature is and how to actually make a thermometer and what temperature is not as well. So temperature is a measure of the average kinetic energy. Temperature is not heat. I know in common day we reference those two as meaning the same, but they are absolutely not the same. And I want to just take a minute to talk about that as soon as I'm done here talking about exactly what kinetic energy is, so I can tell you how temperature is not heat. So one thing I want you to take note of is whenever you see the word kinetic energy in one of your problems that you'll be doing maybe on CASEL Learning or any worksheets or any tests that you take, you can always exchange the words kinetic energy for the word temperature. They are synonyms. Temperature is a measurement of the average kinetic energy of the substance. And kinetic energy is energy of movement. So kinetic energy is energy of movement. So the faster something moves, the more kinetic energy it has. Now, it is an average, so you take a substance, say a liquid substance, and there's 1,000, well, there'll be more than 1,000. Let's just say it's like a little drop, and you have 1,000 molecules in there, and most of them will be moving really fast, but there will be a few in there that'll be a medium speed or a slow speed. The average of all of those molecules together is going to be the temperature. So temperature is not how fast the fastest molecule is moving in that substance or how fast the slowest molecule is moving. It's the average of their movement. The equipment used for measuring temperature, as we know, is the thermometer. And the units that we are going to be using in class for temperature is going to be the unit Kelvin or Celsius. We do not talk about Fahrenheit, and we only work with Kelvin or Celsius because those are the easiest and the best units to use in terms of mathematical calculations, as well as the rest of the world uses Kelvin and Celsius as well. So that's what we'll be using. Now what I want to do is I want to go back and talk about this whole thing, how temperature is not heat. Just because something is hot doesn't mean it has more heat. Sounds really odd, but I want you to take it, maybe a look at this. So I have got obviously a hot cup of coffee and a very cold lake because it is frozen. But I'm telling you that this lake, very, very cold lake, has more heat energy in it than this hot cup of coffee. This has more heat energy. This is what I mean by this. So let's just take the cup of coffee first. Let's just say for purposes we're going to just say that there's 10 molecules in there. Now that's probably going to be multiplied by 1 billion and so in real life, but we're going to slash it and we're just going to say that there's 10 molecules in there because there's obviously a lot less in this coffee cup than there is in the lake of water molecules. And let's just say that its temperature is high, which means the average movement of those molecules is really high, and I'm going to say the average is 100. So if I take the 10 times on the 10 molecules, and let's just say each of them averaged about 100 in terms of their kinetic energy, that's going to give me 1,000 energy units. Let's call that my heat units. And I'm simplifying this because we'll be doing this in a different unit later, but just wanted you to make sure you don't interchange the word temperature and heat to mean the same. Now let's go up and look at this water. The water in the lake, there are a lot more than 10 molecules. If I'm saying this holds 10, how many coffee cups with that? Let's just say for intents purposes that this is a small lake and it only has 1,000 times what this coffee cup would be. Well, if it's 1,000 times what that coffee cup would be, then it would be let me erase this. Then it would be 10,000 molecules of the water. And we know it's really cold, its temperature is low, so let's just say each one of those 10,000 molecules only has an average of 10. Now down here, each one of the molecules had an average of 100 degrees for their kinetic energy. Up here it's going to be 10. If I take that 10,000 and I multiply it by those 10,000 molecules and multiply it by the 10 units of energy that it has in it, that gives me 100,000 units of heat energy. Look at this. The lake has more heat energy than the coffee cup. Even though the coffee cup is a higher temperature, it does not have a higher amount of heat energy in it. So that's the difference between temperature and heat. Now let's do some conversions. This is where you're going to need your calculator, possibly. So temperature conversions of Kelvin, Celsius, or Celsius to Kelvin, you'll see that you have Kelvin is equal to your Celsius plus 273. Kelvin is always positive, so it is always a bigger number than anything else. It is always positive, which is why we use Kelvin in our mathematical calculations, because multiplying, subtracting, dividing, proportions with negatives sometimes is extremely difficult, if not impossible to do. So we use our Kelvin scale to do our mathematical calculations. One other thing to note, the reason why we use Kelvin is because it's always positive, there's never a negative number, meaning 0 Kelvin, or okay, but 0 Kelvin is absolute, oh boy. Let's get rid of this because this does not look good at all. Absolute 0. So 0 Kelvin is absolute 0, which means negative 273 Celsius is absolute 0 as well. Because if you have a Celsius number and you want to go to Kelvin, what you're going to do is you're going to add. You're going to add that 273. But if you want to go to Celsius, you're going to want to subtract that 273. Because remember, Kelvin is always larger. So if you're going to Celsius, you're going to a smaller number. So you need to subtract. Kelvin is always bigger. So if you're going to Kelvin, you need to add. So what I want you to do is I want you to take a minute and I want you to try and do these 3 problems. Once you've done the 3 problems, then go ahead and see what the answers are. So push pause, do the 3 problems, and then see what your answers come out to be. So I hope you paused it and have your 3 answers. The answer to the first one is a positive 269. You should have subtracted because you're going to Celsius, and Celsius is always smaller, so you should have subtracted 273. Next answer is a positive 210.5. You're going to Kelvin. Kelvin is always larger, so you should have added 273. And for the last one, the answer is negative 158, I believe. Make sure I have that correct. 115 minus 273, because we're going to Celsius. Yep, it's a negative 158 degrees. Again, which is why we use Kelvin rather than Celsius, because in this case, you've got a negative, and negatives are not good to use when we're doing our calculations. So lastly, how you're going to make your own thermometer. So when you come into the room either tomorrow or the next day, what you're going to be given is something that looks like this, which is a scaleless thermometer, and it's going to be filled up with some alcohol, the red alcohol that they use for thermometers, maybe up to that point. What you then do is you're going to need to determine 2 fixed points on the thermometer. Well, the 2 fixed points that we know the temperature of is ice water, and ice water we know is 0 degrees Celsius, so you're going to put it into ice water, and what's going to happen is that liquid is going to, as we learned before with solids, liquids, and gases, the liquids are going to take up less space because they're going to shrink a little bit. They're going to come closer together, liquid to a solid, and the red is going to go down, and however far it goes down, you're going to mark it. So let's just say it goes to here, and you're going to mark it there. And that's your 0 degrees mark. And then you're going to put it into boiling water. Now, boiling water at our altitude will boil at 100 degrees Celsius, which is why, again, why we use the Celsius scale, because let's then say that when you put it in there, the red comes up to here. You're going to then mark it where it comes up, and let's just say that it goes to there is the 100. So then what you do is you have your 1 mark here and your 1 mark there. You take a measurement between these 2 points, and the middle mark is your 50. And you continue to take measurements in between the 2 points, and here it would be 75, and here it would be 25. And you continue to make marks. And then you have a thermometer, because when you put this thermometer then into some kind of water, which I'll have a certain temperature to, you put this in here, it's going to raise up to whatever that temperature is, because how its movement is, the more faster it moves, the more it's going to spread out, and then it's going to go up the thermometer, and it's going to read a higher number on the thermometer. You'll be able to tell me how well you scaled your thermometer, because I'll have the actual temp, and then you will have your temp, which is the experimental, and the difference between is how much error you had. And so we'll be doing that again either tomorrow when you come in or the next day, so make sure you have notes on how to make your own thermometer. Maybe you need to pause it, rewind it, write down the steps, fill out your general lab journal for the procedures, and then you'll get set and ready to go. I'll see you tomorrow.